Assalamualaikum. We are from CS 1114A. So we would like to present about our group project in MAT222. For this course, we choose logical connective as our topic.
So, what are you waiting for? Let's go!
With the bands. Pause with the pause with the put the pause with the bands. Pause with the pause with the pause with the bands. Pause with the bands.
First of all, I will go with the introduction. What is logical connective? Logical connective is a symbol used to connect two or more propositional logics to form more complex proposition. So why is logical connective important? Because we want to clearly state the logical connection between two functional premises, and we can run the conclusion after the logical connective applied. Okay. Before we go deeper, we need to know what is statement. Statement is a declarative sentence that can be true or false but not both. There are two types of statement, which is primary statement and compound statement. Primary statement is a simple sentence that consists of one subject. This primary statement will use the connective logical operator to form a compound statement. Next, what is compound statement? Compound statement is a statement formed from the combination of two or more primary statements. So if you want to know the true value of compound statement, we need to know the true value of its primary statement.
Okay, so let's go into the first logical connective, which is conjunction. Conjunction is used to combine two primary statements into compound statement by using the word and. The symbol is like inverted V. It is written as P inverted V Q and read as P and Q. Okay, so this is truth table for conjunction. To remember this, for conjunction, both statement must be true to get true. So, other will be false. For example, P true, Q true, P and Q will be true. P true, Q false, P and Q will be false. P false, Q true, P and Q will be false. P false, Q false, P and Q will be false. Okay, next, let's go through into this conjunction logical connective. Okay, so this conjunction is used to combine two primary statements into compound statement by using the word or. Symbol is like V. It is written as P V Q, but it is read as P or Q. Okay, so this is truth table for this conjunction. For this conjunction, one of the statement must be true to get the true value is true. For example, P true, Q true, P or Q will be true. P true, Q false, P or Q will be true. P false, Q true, P or Q will be true. P false, Q false, P or Q will be false. Okay, so next is conditional. The symbol is like error. It is denoted by P error Q, but it is read as if P then Q. But in conditional, we can write in many ways. For example, P implies Q, P only if Q, P is sufficient for Q, if P then Q. Q is necessary for P, Q if P, Q whenever P, Q from P. Just the position is difference. Okay, so this is truth table for conditional. For conditional, if P true, Q false, P implies Q will be false. Others will be true. For example, P true, Q true, P implies Q will be true. P true, Q false, P implies Q will be false. P false, Q true, P implies Q will be true. P false, Q false, P implies Q will be true. Okay, so next is biconditional. Biconditional have two. The symbol have two sided error. It is denoted by P two-sided error Q, but it is read as P if and only if Q. Okay, so this is truth table for biconditional. For biconditional, the easiest way to remember, if the statement have the same true value, the true value for P only and only if Q will be true. For example, P true, Q true, P only and only if Q will be true. If P true, Q false, and P and only and only if Q will be false, and same goes to others. So let's go into the last logical connective, which is negation. Negation have two symbols. It can be read as not P. For the true value, it is inverted to the true value of statement. For example, P true, not P will be false. P false, not P will be true.
Now, let's see for our example that we provided. The first one is for symbol to sentence, and the second one is for sentence to symbol. So before I start, I want to let you know that I already highlighted with the same color to mention the same symbol and word. So for the first example, symbol to sentence, let P, Q and R be primitive statements denoted as follow. So P as Ali practices mathematics every day, Q as Ali missed the midterm test, and R, Ali obtained a good grade in exam. Okay, so the first symbol, not Q, symbol of biconditional to R. So the answer is Ali not miss the midterm test if and only if he obtained a good grade in exam. So for the second Roman, open bracket, P and not Q implies R. The answer is, if Ali practices mathematics every day and he not miss the midterm test, then he obtained a good grade in exam. The third Roman, open bracket, P and Q or not Q and R. The answer of the sentence is, Ali practices mathematics every day and he missed the midterm test, or Ali not missed the midterm test and he obtained a good grade in exam. So for the last Roman, not open bracket, P or Q implies not R. The answer is, it is not true if Ali practices mathematics every day or he missed the midterm test, then he is not obtain a good grade in exam. For the second example, which is sentence to symbol, the question is, let P, Q and R represent the following simple statement. So P for banana is delicious, Q watermelon is delicious, R durian is delicious. Okay, the question is, banana or watermelon are not delicious and durian is delicious. The answer in symbol is not open bracket, P or Q and R. The second one, if banana is not delicious, then watermelon and durian are delicious. The answer is not P, implies Q and R. The third one, it is not true that banana is delicious if and only if watermelon or durian are delicious. So the answer is not P, the symbol of biconditional, Q or R.
Okay, now we move to the true value. For this subtopic, the example is given that the true value of open square bracket, open first bracket, R implies S, close first bracket, and open second bracket, R only and only if T, close second bracket, close square bracket, and not S is true. Identify the true value of S and T. For this subtopic, you need to construct a table. There's two rows. For the first row, you need to make a column for each letters and symbol. And for the second row, you need to identify whether the symbol, each symbol and letters is true or false. State T for true and F for false. Back to the question. The statement said that the equation is true. So we need to put T below N. Between the square equation and not S. So for the N is a conjunction. To get true for conjunction is true and true will get true. So we put true under the square bracket and true under not S. For the true for square bracket just now, we put under N inside the square bracket. So we know true will become true for conjunction. So we put true below symbol conditional and biconditional, which is implies and only if. So we can start to solve with the first bracket, which is R implies S. So we know implies just now we get true, and S we will get false because not S is true. So to get true for conditional is true made true, or false made true, or false made false. So as here is false, so false made false will become true. And now the second bracket is by conditional is true. R just now is false, so we can put R here is false too. And then to get true for by conditional is true made true, and false is made false. So R is false and T obviously is false because it will become true. So the value of S is false and value of T is also false. Okay, next for the second example of true value is given that the true value of open square bracket, open first bracket, not P or Q, close first bracket, and open second bracket, P or R, close second bracket, close the square bracket, implies R is false. Identify the true value of P and Q. As I said just now, for this subtopic, you need to construct a table, and I already construct a table for this question, and I already make a column for each letters and symbol. Okay, back to the question, for this statement, it state that it is false. So I need to put false under implies, which is conditional one. So to get false for conditional is true made false will become false. Okay, so I will put true under square bracket equation, and R is false. Okay, now we go to the square bracket equation. Like I said just now, it is true, so I put true below and symbol n, and I can solve the second bracket first because we know R is false. So n just now is true. To get true for n is true made true. So for the or symbol, we will put true for both in the both bracket, and then for the second bracket, R is false. So to get true for or, it's true made false, false made true. So here R is false, so it will the P will become true. True made false will become true. And then for the first bracket, we know that P just now is true, so not P is inverse, it become false. So to get true for R, false will made true. Only false made true will become true. If it started with false first. So Q is true. So the true value of P is true, and true value of Q is also true.
For the conclusion, we learned that logical connective symbol used to stand for the relationship between statements. And based on the previous slide, we'll also learn logical connective, which is conjunction for and, disjunction for or, conditional if then, biconditional if and only if, and negation not. We also learn that true value is the attribute of proposition that determines its true and falsity.
That's all from us. Bye.